Professor in EC Department at SNS College of Technology. In this lecture video, I am going to discuss about the topic name is realization of IIR filter from Unit 2 IIR filter design. From the subject name is digital signal processing. Here let me discuss. In digital system processing, infinite impulse response filters can be realized using different structures based on their transfer function. These structures affect performance, resource usage, and stability. Here are the most common realization structure for our IIR filter. Uh, that is direct form 1, direct form 2, cascade form, and parallel form realization. In the realization IIR filters, the elementary blocks are the fundamental components used to construct the various structures, which is direct form 1 and direct form 2, cascade, and parallel. These blocks are common in signal flow graphs and block diagrams for digital filters. This is the elementary blocks, which are first one is adder it is nothing but the add the two or more input signals, and simple of adder is here you can see circle with plus sign. The mathematical operation of an adder is y of n equal to x of n plus x of 2. This is mathematical operation. And next one is a multiplier. The function of the multiplier is to multiply a signal by a constant coefficient, and simple is typically a line or box labeled with a coefficient. Here you can see coefficient like y of n equal to a into x of n. Next one is uh, delay element. Uh, Delay element function of the delay element is the delays the input signal by one sample. Like a symbol of delay element, a box labeled z power minus 1, which means here you can see y of n equal to x of n minus 1. And this is the direct form 1 structure. Common structure. Direct form 1 realization is a fundamental structure used to implement IIR filters, which is it is uses the filters difference equation directly and clearly separates the feed forward and feedback IIR path. Here you can see the h of z is nothing but the transfer function of the difference equation. Transfer function of the filter equal to summation k equal to 0 to m bk b suffix k z power minus k divided by 1 plus summation k equal to 1 to n a suffix k z power minus k. And here we will consider h of z equal to h1 of z and h2 of z. H1 of z is nothing but the numerator term, and h2 of us is h2 of z is nothing but the remaining term. Hence h of z equal to h1 of z into h2 of z, where x of n is nothing but the input of the filter, y of n is the output, and a suffix k is the feedback coefficient from previous output. B suffix k is nothing but the feed forward coefficient. Capital N is nothing but the order of the denominator, and capital M is nothing but the order of the numerator. And then this is the you can see the direct form 1 common structure for the direct form 1. Right side is nothing but the h1 of z, and left side is nothing but the h2 of z. Mm, and feed forward path, it implements the convolution of two input, uh, then use delay elements, which is nothing but the z power minus 1 and multiplier b suffix k and adder circuit. And another one is implement feedback path of previous output scaled by a suffix k, uses delay elements multiplier, which means multiplier is nothing but the a suffix k, which is a1 a2 a3 and so on, and adder. Then this is the direct form 1 common structure, and another one is direct form 2. Direct form 2, the transfer function of the h of z is nothing but the summation k, normally summation k equal to 0 to capital M bk z power minus k divided by 1 plus summation k equal to 1 to capital N a suffix k z power minus k. Here we consider h of z equal to y of z divided by x of z, which means output divided by input. This equation we will consider we will assume the y of z divided by w of z into w of z divided by x of z. Let me assume this equation y of z divided by x of z to y of z divided by w of z and w of z divided by x of z. This y of z divided by w of z, let me consider as a numerator of the transfer function, and uh, w of z divided by x of z, let me consider as the remaining part of the term, remaining part of the h of z. So both h1 of z into h2 of z, which is equal to h of z, and this is the common structure for the direct form 2 realization. Left side is nothing but the w of z is sorry x of z divided by w of z, and right side is nothing but the w of z divided by x of z. And another one is cascade form. uh, in cascade form, we will consider as a h of z equal to one difference equation, h of z equal to y of z divided by x of z. We know y of z is nothing but the um, output of the system, and x of z is nothing but the input of the system. And then h of z going to decimate into two part, which is h1 of z and h2 of z. This h1 of z realized by using direct form 2, and this and another one is h2 of z going to realize the direct form 2. Then both the output going to connect in the series in manner. This is the um, uh, uh, cascade form. And let me do one small activity. uh, the question mark, can you find the what is the value of this question mark? This is the small activity. If you find some answer, you can comment me, I will tell you. Let you continue. Okay, this is the cascade form. First one is series h1 of z and h2 of z going to connect in the series in manner. And parallel form, this is the common format for the parallel form, and h1 of z h2 of z going to realize using direct form 2. Then these two going to connect in parallel in manner. This is the parallel form realization. And assessment of this lecture video is define realization block diagram, then mention what are the structure to represent the block diagram, and system transfer function of LTI DT, which means linear time invariant system, discrete time system is dash. List the summary of what are the elementary blocks, and uh, identify the difference equation for this diagram. Okay, this is the assessment question. If you have any doubt, you can ask me through the comment. We will meet in next video lecture. Thank you.